Hey folks, Mr. Ray here. We're going to continue on with our factoring unit for polynomials. This is the last method we're going to do. This is called, well, the main method here is called difference of squares. Now, the title is a little bit longer than just using difference of squares. It's also got factoring perfect square trinomials. And to me, that's not really a technique. It's a shortcut. Okay, and we'll talk about that when we get to some examples. This difference of squares is the most important thing of this lesson, and we'll look at examples and explain the difference between the two. So before I get into some examples, I want to go back to lesson, I believe it was lesson 2, when we looked at some special cases or special factors of binomials. The first one was when we took the same binomial. I'll just represent it with a plus b. If we squared it, meaning we're basically taking a plus b multiplying by a plus b. If we do the FOIL here, or matrix method, whatever you want, you're actually going to get, for the a plus b squared, you're going to get a squared plus 2ab plus b squared. Okay, and if you did the same thing but you had a minus sign, a minus b squared, you would get a squared minus 2ab plus b squared. So the only difference was the plus or minus sign in between. So what we're going to be showing in this lesson is recognizing when you have a trinomial that looks something like this and be able to go directly to one of these two factors. So I'll show you the shortcut. Whether or not you use it is up to you. It does save you some time, but you could get through life definitely without using the technique of recognizing perfect square trinomial and going back to this. So if I reverse the order here, basically if I give you something that looks like this, a squared, and notice I got plus or minus 2 times ab, and the a and the b are both here as well, plus b squared, we know that's going to factor directly into a plus or minus b squared, and whether it's plus or minus depends on whether that's plus or minus. Okay, so that's the difference. Sorry, that's the perfect square trinomial factoring. Again, when I do some examples, I'll go into a bit more about that. Now, here's the important one. If you remember when we had the special factors or special cases of binomials, this time instead of them being exactly the same, a plus b, and these would be a plus b, a plus b, a minus b, a minus b. This is where you have both a plus and a minus between them, but the first terms are the same and the second terms are the same. So we know when we actually FOILed that, we got a squared minus b squared because the outside and the inside multiplications canceled each other out. You had a plus ab and a minus ab, and they just added to 0, they cancel out, and you're left with that. So the difference of squares factoring is going backwards. If I give you something that looks like this and ask you to factor it, you know that the factors of a squared minus b squared will be a plus b and a minus b. It's just going the opposite direction because remember, factoring is the opposite process of expanding. Okay, so remember that's what we learned in lesson 2. Now what we're going to do is do the factoring part. So it's a fairly short lesson. I've got 4 examples of each, and hopefully that's enough to get you going. Now, so we're going to start with difference of squares because that's the real important one. If you follow the technique I use, I guarantee this will be the simplest, the easiest of all the 4 methods, including common factoring. And I'm always surprised when students mess this up because it's fairly straightforward marks for you. Okay, so now let's look at some of the things we probably already talked about. Oh yeah, and don't forget, you should always look for a common factor first. Even when you look at it and you think, oh, that looks like a difference of squares, you should always try to see if there's a common factor there first. And we'll have an example that's got that. And when you do see this pattern, if you're trying to factor something that's like a squared minus b squared, you figure out what's the a, what's the b, and the factors will be a plus b and a minus b. So let's look at that here. Now, one of the skills to have here is recognizing numbers that are perfect, that are squares. Okay, so we call those perfect squares. So these are numbers like 1 squared, 2 squared, 3 squared, 4 squared, so on. So it's important to be able to recognize those numbers so that when you're doing this technique, you can say, oh, this is going to work because the numbers are perfect squares. So I'm going to list them here up to 100. 1, so that's 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. And you might see a couple higher than that, but these are the important ones. You'll see these numbers quite a bit, and if you do a quick scan here, you can see, these 5 here are all perfect squares. So here's the little checklist that I recommend. So remember, I'll just repeat this. We're looking for a squared minus b squared, and the factors will be a plus b, a minus b. Now, you have to be able to recognize, is this a candidate? Can we do can we do difference of squares factoring here? So here's the little checklist. It's a very easy checklist that you would look at. Can I do difference of squares here? So the first thing is, are there 2 terms? And remember how to tell the difference. You can use the plus or minus sign to subtract to separate the terms. So you count the number of terms. If there's 2 terms, you keep going. Are those 2 terms being subtracted? So is there a subtraction sign in between the 2 terms? And then finally, this is the strange one. You see if you can take the square root of each of the terms. So I just call that square rootable. I don't think that's really a word, but you know what I mean. So let's get down to it. So we've got the first one here, x squared minus 100. Let's go through our quick checklist. 2 terms, yes. Subtraction sign between, yes. Can I take the square root of each of these? So if you have a variable to a power, you always know if you can take the square root if the exponent is even. So if it's, most of the time you're going to see 2, but it also works if it's 4 or 6 or 8 or 10. You can keep going. So that's how you know if a variable term or part of a term is square rootable, because it's a variable to an even exponent. So yes, that's square rootable. And 100, is that square rootable? Yes, it is. I can take the square root of 100, and it's a nice integer of 10. So square rootable means if I took the square root of it, would I get a nice integer if it's a number? Okay, so if it's 101, it's not square rootable. So once those 3 things have been checked, you immediately do this. You want to put it in the form like it is up here. We want to know what is the a and what's the b so that we can write our factors on the next step. So this is the step that I highly recommend, and students that do it never make mistakes on this. Students that don't do this, sometimes they'll make mistakes. So it's up to you. If you want to, roll the dice, you can jump right to the answer, but I see quite a few just silly mistakes that are avoided if you set it up like this. So you'd always do this on the next line, and then you figure out what goes inside each of these brackets. So if I want to make an x squared, what goes inside the bracket? Well, obviously that's an x. If I square an x, I get x squared. What goes in this bracket, so that if I square it, I get 100. And that's going to be 10. 10 squared is 100. Okay, and you may think, well, what's the point? That's not giving us much, but it is. The first set of brackets is our A term, and our second set of brackets is our B. So now we can go right to the final answer. We can put our two brackets with binomials. Our first term in each of them will be the x. Our second term in each will be the 10. And we have a plus or minus. And we're done. It doesn't matter what order you put the plus or minus. So that's how straightforward this is. So first you do your check, then you write it as empty bracket squared minus empty bracket squared. Figure out what goes in the brackets. That's going to be your A and B, and then directly from there you go and create your two factors. So let's do it again with this one. Okay, so two terms, yep. Subtraction sign, yep. Square rootable. So look at each part of the term. If it's got multiple components to the term. So the 4, is the 4 square rootable? Meaning, is it a perfect square? Yes, it is. What about the x squared? Okay, well, it's a power of 2. So that's even, so that's okay. How about the 9? Now, you're not thinking about minus 9, you're just thinking about 9. 9 is a perfect square, so that's good. And y to the exponent 2, that's even, so we're all good. Then we write our little template, empty bracket squared minus empty bracket squared. What goes in the brackets? Okay. Now I get students that try to do this too quick, and they'll just put 4x inside, thinking about just the x. If I put 4x squared, that means I'm squaring the 4 as well. That would be 16x squared, which that's not. So what do I have to square to get 2? Sorry, what do I have to square to get 4? Well, that would be 2 squared. And what do I have to square to get x squared? That's 2x. Okay, and you can always double check. You go back and you say, okay, if I square 2x, I get 4x squared, good. And then the second part, what do I have to square to get 9? Well, that would be a 3. What do I have to square to get a y squared? That would be just y. Check again, 3y times 3y is 9y squared, we're good. Okay, and then when I write my factors, first term of each factor is 2x. Second term of each factor is 3y. And a plus or minus. Order doesn't matter. Okay, let's go down to this next one. It's getting a little busier. So do our checklist. Two terms, yes. Subtraction sign, yes. Square rootable, so do each part of each term. 81 is a perfect square. A to the power 2, that's even. B to the power 4, that's the first time we've seen that. 4 is an even exponent, so we're still good. Go to the second term, 64, that's a perfect square. It's up on our list. X squared, we know that's square rootable. Y to the power 6, again, that's an even exponent, so yes, it passes all three checks. So we go to our template that's going to help us create our factors. What do I have to put inside the bracket? Well, to get the 81, I'm going to have to square a 9. 9 squared gives 81. To get a squared, I have to have just a. And to get b to the 4, I need to have b squared. And here's where you would check. 9 squared is 81. A squared is a squared. B squared squared, remember the power of a power rule, you multiply. So that's b to the power 2 times 2, which is 4. And that's good. Over here, we've got what I have to square to get 64, that would be 8. What I have to square to get x squared, that would be x. And here, you have to be careful, y to the 6. So I definitely have a y there. What's the exponent? Don't make the mistake and say it's 4 because you're not adding the exponents, you're multiplying. So the exponent here multiplied with 2 would give me 6, so that has to be a 3. Okay, and then we've got everything we need to create our factors. I have 9ab squared as my first term, 9ab squared, first term on both, 8xy y cubed, 8xy cubed, plus, minus. Done. Okay, and that's how quick it is. It's, I mean, you could definitely go right to the final answer, but this is always the safe first step that allows you to make sure you got everything's set up right. Okay, last one here. We've got, I'm going to do our check. So I've got two terms. I've got subtraction sign, check for square rootable. We've got a problem here because 98 isn't a perfect square. And 450, if you put that in your calculator, that's not a perfect square either. So what's happened here? Okay, this is where we go back to our first key note here. Always look for a common factor first when factoring a trinomial. Well, we didn't here, but there actually wasn't a common factor, so we got off lucky there. This is the case where you got a 98 and a 450. Okay, and I know those are big numbers, but you can at least see they're both even. So you definitely know a 2 comes out. And if you try anything like a 4 or a 6, nothing seems to work. So let's just try it with a 2. So I'm going to put a 2 with square brackets. When I common factor the 2 out, divide the 98 by 2, I get 49. Now when I divide by 2, I'm just dividing the coefficient, right? Not the variable parts aren't affected. 450 divided by 2 is 225, b squared. And now if I check again, I can see, oh, the 49, that is a perfect square. And the 225, even if it's not on my list, get your calculator out, square root of 225 is 15. Exactly, that means it's also a perfect square. So we're good to go. So keep the 2 there, 2 doesn't disappear. And then now I go and put my template inside the square brackets, like this. So what goes inside the bracket when I square it, I get 49a squared. So to get the 49, I need a 7 squared. To get the a squared, I need an a. You can check it, make sure it expands to that. 225, I need to square 15 to get 225. And I need to square b to get b squared. And now we're set with our final answer. Again, you leave off the 2, it's wrong. So just because you divide it by 2 doesn't mean you can forget about it. The 2 is a factor that needs to be there all along, every step. Okay, so now we know the first term is going to be 7a, second term is 15b, plus or minus, and we're all done. Okay, so hopefully that gives you a good start on how do you use the difference of squares factoring technique. Again, I can't emphasize enough the importance of doing that middle step. It really makes sure that you get the right terms. And also don't forget, anytime you do factoring, you can always expand your answer and make sure you get back to the original question. Okay, like I could actually do FOIL on here and make sure I get back there. But after you've done a few of these, the confidence level is pretty high on these guys. Just make sure you do that first template step. Okay, so let's go to the other method. So this is the perfect square trinomial. Now, I'm reluctant to call this a method. It's kind of a shortcut. So remember from our first page here, if you have something that looks like this, a squared plus or minus 2ab plus b squared, and a and b could be any terms or numbers. If we see something like that, we know the factors will be, this is a perfect square trinomial, so the factors will be either a plus b squared or a minus b squared, matching up to whatever sign that is. Okay, now, if that's the first question, I would say if I gave you that question on a test, you probably wouldn't even think about perfect square trinomials. You'd just go, okay, I'm going to use simple trinomial factoring and get your answer. And then at the end, you'll go, oh, look at that. Both of the factors are the same. And then you'll realize, oh, this actually is a perfect square trinomial. It's got the same factors squared. Did I need to do the shortcut to do that? No. But here's how you could use the shortcut. So, and the trick here is, again, sort of using a template. If you think it might be difference of squares, sorry, perfect square trinomial, you're going to set it up like this. Okay, I shouldn't put the B there, sorry. Okay. So I've got a little template here. You notice I've got basically the first and last terms are empty brackets squared. So we always start with that. So I'm trying to turn the first and third terms into that, see if they're perfect squares, and they are. So I would actually put an x inside the bracket. X squared is x squared. And here I would put a 3 because 3 squared creates the 9. And now I would remember from here, back here, this middle term here is plus or minus 2 times AB. And these are the A and B. Okay, so if I multiply A and B, I get x times 3 or 3x. And I'm going to put that inside here because that's AB. And now I can see that's actually going to create, if I just multiply these two together, it would be plus or minus 6x. Okay, so if this is a perfect square trinomial, this number should match with this, this term should match with this term, and it does. The only way this could be a perfect square trinomial if that was a plus 6x or a minus 6x, and it's a plus 6x, so we could go right to the fact that it's a perfect square trinomial now. So it's going to be the same trinomial times itself, or squared, and the first term is x, the last term is 3, the a and the b. Remember, the a and the b come from these two. And then the last thing is this going to be a plus or a minus? Well, remember I said this could have been a plus 6. If it's a plus 6x, this will be a plus, and it is. It's kind of, you can't really see it there anymore, but it was a plus 6x, so that has to be a plus. Okay, and to check it, you could expand it. Now, like I said before, this is a bit of a shortcut, and you probably wouldn't write all this out. You do it in your head. You go, okay, the a is x, the b is 3. That's multiply them together, 3x. Double them, we get plus or minus 6x. Okay, it's a perfect square trinomial, so I could jump right down here with your answer. Okay, if you do it the other way, I'm never going to ask you a question. Factor using perfect square trinomial, and if you just bypass that and just used your simple trinomial factoring and got that, that's okay. But I just want you to see the shortcut to see how it works. There could be other questions around it. For example, I could ask you, is this trinomial a perfect square trinomial? And then justify. Yes, no, and justify. Okay, so this one here. So again, I'm going to put it in this form. If I'm going to test it out, so it's 2 times box plus bracket squared. So then I kind of fill in the first and last based on these two terms. So x squared, I need an x there. 36, I need a 6 there. What goes inside the box? That would be 6x. So this creates plus or minus 12x. Now we check back up here. Does that match? Yes, it does. And if it does match, it's a perfect square trinomial. And we can go directly to our factors, which is the same factor squared. And it's going to be x first term, 6 second term. And this time, you notice the sign there was subtract. So that's the sign in our factors. Okay, let's keep going with maybe something a little harder. So if we wanted to test, we'd put our template here, something squared plus 2 box plus something squared. Okay, now what goes in the box here? Sorry, what goes in the brackets here? What do I square to get 4x squared? That would be 2x. What do I square to get 49? That would be 7. What goes in the box? These two multiplied, that would be 14x. So, forgot my minus sign there. I could have plus or minus 28x, and that does match up with that, which means it's a perfect square trinomial. So, create our factor squared. It's going to be 2x first term, 7 is the second, and because that's a plus sign, this is going to be a plus. Okay, last one. Set up our template, bracket squared plus 2 box plus bracket squared. Fill in the brackets, 25k squared, so I would have to square 5k. And 36m squared, I'd have to square 6m. Okay, now this is a little more complicated. I got two variables. If I multiply these two brackets together, the a and the b, I get 30km. Sorry, I forgot my minus sign again. And so we just multiply that. If I have a 60km, plus or minus 60km as my second term, and I do, then that means this is a perfect square trinomial. If that was anything other, if that was, say, minus 65km, we couldn't do, this is not a perfect square trinomial, and therefore it's not going to be the same factor squared. So now we put in our factor squared. So the first term of that factor will be 5k. Second term will be 6m. And then the sign will be the same sign as the term in the trinomial. So there we go. So all of these are perfect square trinomials. We were able to tell that once we got here and we checked what the middle term should be and what it actually was. If they match, it is a perfect square trinomial, and then it's very easy just to go right to the factors. Just be the same factor squared. Okay, so, but like I said, you still have to know how to check to see if something is a perfect square trinomial. I could ask a question like that, but I will never say use perfect square trinomial factoring to factor this. If you see something and you have suspicion it's a perfect square trinomial and you do quick mental math and you determine it is, you could definitely go directly to the final answer in each of these cases. But you would be doing, it's not just a guessing, you're actually calculating what would the middle term have to be for this to be a perfect square trinomial. And then if it matches, it is a PST, and then you can just write it as a binomial squared. Okay, so emphasis on this is really on the difference of squares factoring. So make sure you practice those questions and make sure you're good at that. Now there'll be the next lesson will just be kind of it's an important lesson because now you know 4 different techniques for factoring. You've got common factoring, simple trinomial factoring, complex trinomial factoring, and what we did today, difference of squares factoring. Now the problem I've seen in the past is students, they get their homework for each type of factoring and they go through the homework, no problem. But if at the end of the unit, when I give you a test, you're not sure what method to use because you don't really have kind of a flow chart in your head that tells you that what you should be looking for to know which method to use. So that's what we'll be doing in the next lesson, lesson 7. And then at that point, part of lesson 7 will be like 100 plus factoring questions, all randomly chosen, not grouped by the type of factoring. So that will allow you to apply your model, your flowchart to choose the right method and then use it accordingly. Okay, so please practice, like I've said before, on all the other factoring techniques, please practice the questions. You can't get good at it if you don't practice yourself. It's not good enough just to look at me doing 4 examples on a piece of paper. You have to do it yourself. Okay, that's all for today, and I'll see you on the next lesson.